So, doon na class tayo with the first three parts. Medyo mahaba talaga yung acid base kasi this comprises a lot of titration methods talaga. And now, we move on class 2, complexometric and precipitometric titrations. So, did you know slide muna tayo? Complexometric titrations have been used for over a century with major advances starting in the 1940s through the use of chelates. O class, baka familiar na kayo sa word na chelate. So, chelates are compounds where a metal ion binds to a ligand, forming stable ring structures. Yung tawag naman natin class sa mga ligand that can form chelates are chelating agents. Example, glycine. So, glycine having oxygen and nitrogen as its donor atoms can form stable ring structures with metal ions. Ito yung kanyang 3D structure. Ito class water lang to. Diba? Ganyan class ang example ng mga chelates. So, for more terms, for more in-org related terms, you will also have this. Or baka tapos na kayo, okay? When you are now watching this video sa advanced in-org na class. In-org 9 and 10 will be about coordination compounds. So, doon yung class mas malalaman lahat ng terms, mas maalala lahat ng terms na related sa metal, ligand, and sa mga complexes. So, ang chelate, example to class ng mga complex. Okay, let's look at more terms ha. So, ito class, ito ay para lang sa analytical chem. Of course, you have more general terms in in-org. Well, let's start. Organic compounds that contain both amino and carboxylic groups, and they are used as ligands in titration. So, both functional groups are present, amino carboxylic acids. Any organic compound with two or more binding sites that can simultaneously coordinate to a metal ion, ito nga yung chelating agent. And the complex or the compound formed from metal ion and chelating agent, ito class ang chelate. So, ito class yung mga terms no, na important here sa lesson natin. So, when your titration method involves a chelating agent, when you want to analyze a metal ion, kilometric titration. The most widely used chelating agent, syempre class, sobrang familiar sa atin ito, EDTA. Okay, so multiple coordination sites. To be exact, there are 6 sites of binding for EDTA. At dapat class, kapag EDTA, masaya tayo. Bakit? Ang ratio nito with any metal ion is 1:1. Okay, hindi na kailangan problema sa pagbabalance kasi laging 1:1. Okay, so class, very simple terms lang before we begin with our lesson on complexometric titrations. And then here, let's look at some uses. Anong mga practical applications ng complexometric titration? Syempre class, number 1 na dito, ang metal ion determination. Ang mga chelating agents, ang mga complexing agents, they are used as titrants. So, ang analyte, ang mga metal ions. Okay, so nearly all metals can be accurately and rapidly determined by complexometric titration. And class, faster and more convenient than gravimetric methods. Sa naman sa Anachem 3, diba? Na medyo tedious, laborious ang gravimetric procedure. Okay? So class, kindly read na lang this other uses as your homework. Okay? So ayan. So we now have background. We now have background knowledge about complexometric titrations. Let's now look into different methods, typically with EDTA, guys. So we have direct EDTA, back titration, displacement, and indirect. So you would see here the indicator, no? Very common class for EBT, Erythro black tea. Ang direct EDTA titration, very common for water hardness. So when we say water hardness, your typical ions are calcium, magnesium. Okay, so class, pakibasa ito, hinhighlight ko lang yung madali. Kasi meron tayo later, direct EDTA titration and displacement. Okay, now it's time to look at the structure of EDTA. Ma'am, ilan po ba ang sites for binding ng EDTA? So meron siyang 4 na acetic acid, acetate. Meron siyang 2 amine groups, total 6. So when you go to in-org, you will again learn the term coordination number. So with any metal ion, the coordination number is 6. There are 6 sites for binding. EDTA is a polydentate ligand. Okay, so matutunan class to, itong mga terms na tututunan in org. So grabe naman ma'am, ang strong naman ng EDTA. Exactly. It's a strong chelating agent that forms stable 1:1 complexes with many metal ions. Ma'am, promise ha, kahit anong metal makita namin sa problem, laging 1:1, yes. So yan class ang EDTA. Okay, laging ganito ang ratio niya. Also, we need to look at how stable ba talaga ang complexes ma'am na napoform ng EDTA with metal ions. Class, the constant here no, na involves the formation ng complexes is called the formation constant. I hope class meron kayong naaalala pa sa equilibrium lessons before. So diba, sa solubility, the constant was KSP. Sa acids and bases, the constant was Ka and Kb kasama ng Kw. Here, in complexation, Kf, formation constant. Ma'am, bakit? Puro positive yung exponent. Sanay po kami na negative yan. Class, ibahin nyo ang Kf. For Kf, their exponents are positive and stable. Di ba nga, stable complexes ang naform ng EDTA with many metal ions. And it shows sa formation constants na to, how stable, how favored ang formation class ng EDTA complexes. I hope clear tayo dito ha. Ganyan, kagaling class ang EDTA. Another thing that you have to remember for EDTA, dahil nga sa structure nito na tetraacetic acid and ethylene diamine, dapat class nakita nyo na ito ay may influence ang structure niya ng pH. So let's take a look at this ladder diagram. So class, para madali lang i-symbolize ang EDTA, Y ang ginagamit na letter. So if all of the possible na pwede lagyan ng protons ay meron, the formula is H6Y2+. Balik tayo sa structure ng EDTA here. So, pag sinabi natin fully protonated form, your amino groups, and of course, itong 4 na acetate, merong H, merong proton. So, fully protonated. Kaya 6, okay, ang proton sa class, kung pinaka-acidic na form ito ng EDTA. Balik tayo ulit doon. So, this is your fully protonated form of EDTA. As you remove the protons, of course, tumataas yung pH. So, this is your neutral EDTA upon the removal of the 2 protons of the amine groups, and then ito class yung 4 na Kas kasi nga tetraacetic acid. And when you reach 10.24 and beyond, ayan na, ito na class ang fully deprotonated form of EDTA. In fact, guys, you have to remember, kung nag-perform kayo ng EDTA titration before, that a buffer is really added. Para saan po yung buffer, ma'am? Para class, ito yung form ng EDTA na dominated niya, yung lahat ng species. Siya yung dominant form ng EDTA during your titration. Bakit ma'am? Hindi pwedeng lahat sila present. Siyempre class hindi. Hindi ang chaotic ng titration nyo kung maraming forms ng EDTA ang present. So we want a dominant form. Kailangan ma-dominate na class yung titration. So if you are to buffer your titration medium from pH 10 and beyond, example 10 to 12, then you have the Y4- as the dominant form of EDTA. So class, yes, may effect ang pH in titration. Okay. So class, let me show you a video clip of an example ng pag-determine ng water hardness via EDTA titration. And some of you baka nagawa ito as experiment before.
Tap water in our region in Crete is considered to be very hard. Although this poses no harm for our health, there are certain disadvantages. Soap and shampoos do not lather enough, lime scale accumulates in faucets, pipes, drains, washing machines, and boilers, and corrosion affects
Okay. So, kasi nakita nyo itong color change, no? I-explain na pa kung ano yung implication ng water hardness. So, you saw the color change kanina from red to blue. So, yan class ang EBT na indicator. Explain bakit red siya at the start. At the start, pagka-drop natin class ng EBT solution, it will complex with the metal. Kasi class ang EBT, just like the ligand, Lewis base din yan. May donor atoms din yan for the metal ion. Or recall from in org 6, ang metal at saka ang ligand, they can form an acid-base reaction. Ang definition nito class ay Lewis. Metal ions accept the electrons, they act as Lewis acid, and then your Lewis base naman act as the electron pair donor. So, here in our complex symmetric titration, metal ang Lewis acid, and ang indicator at literal EDTA, sila ay mga Lewis bases. O balik tayo dito sa lab. So, red yung color ng metal EBT complex. However, as you add EDTA, yung tatay ka. Di ba class, alam natin na strong chelating agent ang EDTA. Stable ang complex na i-perform ito with the metal ion. Therefore, mas meant to be ang metal ion with the EDTA ligand. So sila talaga class mag-perform ng complex. And kapag dumating na tayo sa point na natatay na most of the metal ion, then the color change will happen. Because if you free up na class, okay, ng EBT, kasi nga, mag-displace na siya. So EBT will be displaced. It will now be free of the metal ion. And nag-react class ang EDTA with all of the metal ion. So the color of free EBT, iriochrome black tea, is blue. So at the end point, color blue siya class. So generally, we call these indicators metallochromic because they complex first with the metal. And of course, we see the color change at the end point. O, diba? So kailangan magkaroon ng displacement exactly para ma-observe natin class ang endpoint kapag na-titrate na lahat ng EDTA ang metal ion. Alright? So yan. Kaya class meron tayo dito ng short portion on iriochrome black tea. So yun ang kanyang color class you already know. And stable ito solution. Actually, unstable siya in solution. It should be freshly prepared every time na meron kayong EDTA titration. Limitations, not suitable in very acidic or very basic conditions dahil nga katulad ng ibang ligand, ito ay sensitive class sa pH. Kaya when you titrate, the effective pH range must be maintained. So kailangan daw class ma-buffer ito at around pH 10. Common buffer na ginagamit, ammonia-ammonium buffer. Common use for hardness analysis. Ligand type, it's a chelating agent as well. It's a weak chelating agent that forms unstable complex with metal ion. So para clear, just a chelating agent din. Class structure niya. So meron din siyang mga donor atoms like nitrogen and oxygen. Mechanism, so we already know that EDTA will displace or replace EBT from the metal and from the metal EBT complex. Dahil nga, mas stable ang na-form na complex ng metal and EDTA. Highly favorable yon. Alright, so yun ang ating portion on EBT. Class, solve tayo ng problem. So this is not in your manual. You have to solve this. Everyone game. A 100 ml water sample required 23.63 ml of 0.0109 molar EDTA for water hardness analysis. Calculate the hardness in calcium carbonate milligram per liter. So class, ang molar mass na 100 lang. So ma'am, 1:1 ha? Yes, 1:1. So calcium reacting with EDTA in a 1:1 manner. Class, ang amount ng calcium ay equal sa amount ng EDTA. So we just multiply the molar and the volume. So cancel. Yan na yun. And then i-expression na lang class into milligram calcium carbonate. So this is your mole EDTA, mole calcium. This is your molar mass of calcium carbonate. Siyempre, 1 mole calcium, 1 mole calcium carbonate. Yeah, shortcut ko na. Then convert gram to milligram divided by the volume of water used. So very easy class. If you want, you can pause the video, solve on your own. Kasi class, you will build confidence. Okay, habang kayo ay nakakapag-solve ng tama. 1A, dapat ginagawa nyo yung best nyo. Tandaan nyo, hindi tayo nasa onset class. Unlike ang 1B to 1F, I can really command them, solve this. Nasa antayin ko. 1A, kayo ay narinig lang yung boses namin. So hopefully, you do your part. Kasi hindi pwede man nakita ko ng paano mo isinolve ako nag-solve nito. Diba? Kailangan ikaw din para ma-build mo rin yung knowledge and skills mo in solving. I hope clear tayo 1A ha. So, kung na pause nyo na, nakapag-answer na, nakapag-calcu. So the correct answer, 258. So kailangan class, naka-express to in the correct number of sig figs, 3 sig figs because of the molar EDTA here. Okay. Ma'am, kapag water hardness ba, common na unit ang ppm? Yes. Kasi konti lang. Konti lang class yung amount ng hard water ions most of the time ha, in water samples. Kaya ppm ang common unit. Milligram calcium carbonate, minsan pwede rin magnesium carbonate per liter. Okay. So class, ito naman nasa manual. So nasa manual to, ito galing sa book ni Skog. So let's read ha. In a 9.57 gram sample of rodenticide, thallium was oxidized to thallium-3 and it was treated with an excess of magnesium EDTA solution. Hala, pag ganyan class, alam niyo na ha, hindi given yung value. Bakit kaya ma'am? Okay. Deliberated magnesium was titrated with 12.77 ml of EDTA. Calculate the percent of thallium in the sample. Let me explain class ano nangyari. So in the beginning, you reacted magnesium EDTA with thallium. Commonly kasi nagawa to for improved endpoint. Okay, so tingnan natin. So paano malalaman yung amount ng thallium in the sample? Of course, it will be proportional to the amount of the first solution na inad. And as you can see, indirectly, malalaman natin kung how much yung thallium present in the sample. So, look at the ratio, 1:1. Whatever amount of thallium was present in the rodenticide is equal to the amount of magnesium liberated. Ano ba yun, ma'am? Liberated is another term for generated or produced. Kasi klase Skog, no? Laging ganun yung mga words niya. Liberated, generated, produced lang ang ibig sabihin nun. Ma'am, paano malalaman yung amount ng magnesium na na-liberate or na-produce? You will react it with your standard EDTA. Okay? So, magnesium now will react with EDTA. So, we do this, especially class, kapag in-observe natin yung formation constants nila. So, magnesium is commonly used for these purposes. So, whatever amount of magnesium was liberated will exactly react with EDTA, your standard EDTA during titration. So, indirectly, malalaman natin class ang amount ng thallium. Game. Equal na naman pala sila, no? 1:1. So you multiply your molar with your volume, meron ka ng mole, and convert ng class sa percent. So you already know kung paano mag-compute ng percent. Ayan. So we just divide this by the mass of sample times 100.98. So ito class ang amount ng thallium present in the sample. Alright? So there you go. Ito naman class, homework nyo. Pero na-solve ka na. Galing dito sa book ni Skog. So class, kayo na ang mag-synthesize. Bakit ganito ang solution for calcium and magnesium carbonate? Ginawa ko naman class, ang best ko para mukha siyang very organized. Kasi nasasanay kayo, di ba? Na pag nag-solve tayo class, very organized, step by step. So pwede nyo pa rin naman, madali nyo sundan. Okay? Para class meron kayong dagdag na homework. So both calcium and magnesium were determined in this analysis. Okay? Very easy lang siya. Alright? So we move on to another complex symmetric method na lumalabas din class sa board exam. Very old na nga to eh. Itong Liebig method. Class, kung sa EDTA 1:1 ratio, ibahin nyo to. Ibahin nyo to. So here, your metal ion is silver, siya ang titrant. Di ba? Kakaiba. Yung metal ion yung titrant and ang analytic class ang ligand na cyanide. Okay, so let's look at this method. It's one of the most widely used complex symmetric titration that involves a monodentate ligand. So di ba kanina poly or multidentate with EDTA. Ito, monodentate na class ang cyanide. There's only one donor atom, which is for the analysis of cyanide with silver nitrate, a method introduced by Liebig in the 1850s. So mas dapat to, luma pa talaga to, ma'am. Kasi class, a long time ago, cyanide determination is very, very important. So this is the complexation of silver and cyanide forming the soluble complex dicyanoargentate. So ma'am, clarify natin yung stoichiometry niya. For every 1 mole of silver, kailangan niya ma'am ng 2 cyanide? Yes. 1 mole of silver, 2 mole of cyanide. So wag na wag yung kalilimutan class kasi magkukulang yung answer ninyo kung gagawin yung 1:1 to. And most of the time, yung 1:1 ratio, yung maling answer, nasa choices din. So you really have to be very, very careful when you see titration of cyanide. Ang ilalagay kaya nila na this method is the leading method. No, do not expect na explicitly isi-state pa nila yung method and the problem. Once you see that the analyte is cyanide, the titrate is silver, leading method na yan. Okay? So sana ha, na-warn ko kayo enough guys. Now, paano malalaman ma'am kung tapos na ang titration? How do you know if it's endpoint? Bago ka mag-add ng silver nitrate, maglalagay ka muna ng indicator na iodide. So when all of the cyanide has now reacted with silver, yung slight excess class ng silver titrate will now react with iodide to form a precipitate that will signal the endpoint. So magiging turbid or cloudy class upon addition of the slight excess of silver titrate there. So yung class ang Liebig method. Now, solve that yung problem na nasa manual ninyo. So tandaan nyo class, 1 mole of silver will need 2 mole of cyanide. You saw the structure of the complex. Silver at the middle, then you have 2 cyanides left and right, linear na complex. A 0.4482 gram sample of impure sodium cyanide. O ayan ha, ganyan yung mga problem. So cyanide being analyzed, being titrated with silver. O see? So dapat may feeling ka na, alam ko na this is Liebig method. Calculate the purity of the sample as percent by weight sodium cyanide. Just multiply the volume and the molar concentration, cancel. And class, itong silver, dapat dito na rin yung ratio. 1 mole ng silver, 2 mole of cyanide. O see, kapag nakalimutan mo itong ratio na to, patay ka, half lang yung answer mo, di kulang. So this is your mole cyanide. Diba? Ginawa ko pang 2 steps. So this is your relationship with cyanide, sodium cyanide, and the molar mass. So gram, cyanide over gram sample times 100, 88%. Very easy, diba? Very easy. Kung di ka magkakamali sa ratio na 1 mole silver, 2 mole cyanide. Alright, so class, isa pa lang yan sa mga typical na inorganic complex forming titrations. Ito so silver with cyanide. So the product is dicyanoargentate, the indicator is iodide, titrate to first turbidity of silver iodide. Diba? Isa lang siya sa listahan here. So pwede rin class ang mercury, nickel, copper, dami ha. O class, tandaan nyo, magkaiba sila ng ratio. So ito ang para sa silver. 1 mole silver, 2 mole cyanide. But if it's nickel or copper, tetracyano, apat yung cyanide. So kailangan nyo rin mag-ingat class. Okay, so you have 4 moles of cyanide reacting with your nickel or copper. So you have to remember class from import na iba kasi yung coordination number ng mga complexes na ito. Okay, so I hope class clear tayo. So na-share natin na info sa inyo on complexometric titrations. Now, let's have our Mitch list. Kasi class no ongoing to kasi nga medyo mahaba itong chapter na to. So we have added here the 2 methods under complexometric, itong with EDTA and Liebig method. So now class, we reached the last part of our lesson, precipitometric methods. So there are 3 under this subtopic. So the first one ay tinatawag class na Volhard method, then there's more, and then the third one is patience. O class, tingnan nyo kung anong method ito. Use the notes in our manual to figure out kung ano ang nasa video na to. Everybody, watch this.
We add a few drops of 0.1 molar solution of potassium chromate as indicator. Place the beaker on a magnetic stirrer and titrate the sample with 0.1 molar silver nitrate.
For sure, class, you notice the difference.
Observe the turbidity appeared as insoluble silver chloride is formed.
Yes, ayan nga. So kanina clear nga yung turbid na because of the silver chloride form. So chloride is the analyte here, silver is your titrate.
As far as the titration goes on, we observe the increasing amount of precipitate.
Well, we're just waiting guys sa color change to persist. Hindi pa rin. Let's just wait guys for a bit.
Close to the endpoint of the titration, the addition of 1 drop of titrant causes the mixture to become red, but the color disappears. The titration is ready when a slight reddish color in the sample is stable. This is due to the red-silver chromate precipitate, which forms only after the entire amount of chloride was precipitated.
Okay, stop na natin. Sabi na stop titrating. So class, what you saw there is more titration, the more method. So kapag involve ang silver nitrate as the titrate, we will also call this an argentometric titration. Kasi nga silver, kaya argento. Okay? So class, more titration yon. The titrate is silver nitrate. The principle is precipitation of silver chloride kasi chloride yung analyte niya. The indicator that you saw, yung yellow solution at the beginning, is potassium chromate. So when all of chloride has now reacted with silver, wala ka ng chloride, so chromate na ang mag-react with silver, forming the red color at the endpoint. So yan class, ang more. Siyempre may Volhard. Okay? Volhard, then there's more. Kaya na sinasabi ko sa mga on-site sections. So kung di kayo familiar class sa mga methods ito, reading homework na to, lumalabas kayo sa exam, objective pa kayo mga question. So kailangan alam nyo ang titrate, ang principle, ang indicator. Class napansin nyo, magkakaiba sila. They also differ. Bukod sa mga principles nila, they differ in how nagkakaroon class ng interaction ang indicator with the medium. Kaya magkakaiba talaga sila ng mechanism. And ito class, medyo common naman yung kanilang applications. Well, I'll give you another way to summarize it. Actually, ay team ko lang. So ito ang titrate in the 3 methods and differences nila class in their indicator. In Volhard, iron 3 the indicator forms a complex with the titrant thiocyanate, red din yung color. And then more, chromate, ang indicator, it forms a precipitate. You saw yung red na precipitate earlier. Then for phagans, adsorption ng class ng mechanism, which may video din tayo later. Okay? So itong nasa manual nyo, ito class yung color na pwede nyo makita. However, class, I remember sa lab, hindi ganun parang kanina, no, ang tagal. So parang ang tagal ma-observe ng colors. Okay? Ang tagal mag-persist ng color, no? So class, ang endpoint dapat, hindi talaga siya super red actually. So when you see the tinge, yun ang tawag namin, when you see the tinge of red, stop ka na. It also already means na ubos na yung analyte and you already starting to form the product, the complex or the precipitate respectively, no? So yan class ang naalala ko sa method na to. And then, magkaiba sila class ng medium. Of course, dahil hindi naman to pre-lab discussion, we will not discuss the entire procedure. Pero dapat may knowledge kayo class sa procedure nila kasi lumabas sa exams before. Volhard is done in acidic medium. Indirect method to. And then in fact, ang ginagamit na acid ay nitric acid. Nasa books yan. More on the other hand, direct method kasi walang back titration involved. And then slightly basic class ang medium. So let's talk about the procedure listed there in your manual. So for Volhard, we add a measured excess of silver nitrate. So the analyte, whatever amount of analyte is present will be equal to the amount of silver na magre-react sa kanya. But you cannot know it directly at the first step. Kasi nga, may excess, may unreacted silver na mapoproduce. And then after that, you react this with the titrant thiocyanate. So here, whatever amount of titrant reacted during titration, ganun karami class ang silver at the first step. And equal na yan or proportional sa amount ng analyte initially present. Kaya pala ma'am indirect, exactly. Ma'am, how will I know the endpoint na? If all of the silver ay ubos na, so thiocyanate will now react with iron 3, forming the red color. Then for more, you saw it in the video, direct lang siya. So chloride reacting with silver, and then pag ubos na lahat class ng chloride, it will now react with chromate, the indicator. O see, ganun lang kadali class, ang Volhard and Moore. So now, meron tayong did you know about the class ng Moore method. Mga German chemist pala sila class, no? Si Jacob Volhard, saka si Carl Friedrich Moore. Although the Moore method for chloride is named after Moore, the basic idea of using silver nitrate to precipitate chloride ay actually first na idea class ni Joseph Louis Gay-Lussac. Yes, the same person na sinasabi natin sa Gay-Lussac's law in the early 1800s. Bakit naging Moore method? Bakit hindi Gay-Lussac's method? It's because si Moore ang nag-refine ng approach where nag-introduce siya ng chromate ions as indicator para madaling ma-detect ang endpoint. Yun pala. Okay? Now, kaya mas kilala siya sa pangalan class na Moore method. So after Volhard, there's Moore, and we now move on class sa Phagans method. Everyone watch this. So at the beginning guys, you see a green colored solution na clear. So yun ang color ng indicator at the beginning. Now, as we add more of your titrant silver nitrate, you see, it's no longer that clear. Nagiging turbid. So just like in the Moore video, chloride din class ang unknown here. And of course, you know, ang reaction nito with silver. Nag-form kasi ng silver chloride. So let's add more titrant. We are looking for the color change, guys. No. Okay, let's look at the endpoint na lang. It's now really opaque na class, hindi na siya clear. Ayun na class, may color change na. I hope you can now see na light pink na class. Okay, nag-stop na yung video, hindi napansin. Light pink na itong color ng mixture. Let's discuss the Phagans method. DCF, dichlorofluorescein. As you can see class, yung structure niya, negative, 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 negative. Yes, overall, negative ang charge ng DCF. Class, before endpoint, negative din ang charge ng whole mixture natin. Why? Chloride, the analyte, is still in excess kapag before endpoint. So alam niyo naman, pag like charges, they repel. So wala pang mangyaring adsorption at the beginning. It's just the initial color, DCF, green talaga. After endpoint, tapos na lahat ng chloride, silver will be in slight excess in your medium, in your mixture. Kaya, magiging positive naman class ang overall charge ng mixture due to the slight excess of silver. Silver, positive, DCF negative, uy, match. Kaya kasi kakaroon ng adsorption. So the indicator will change color once it gets attracted. Nagiging pink siya class upon adsorption. Okay, ito, mas clear yung pagka-pink here. Sabi nga ng mga on-site students, parang siyang strawberry pink. Okay, exactly. So ayan class, ang Phagans method. Like Moore, ito class ay direct. Okay, Volhard naman class ang may back titration. Now, for the last part of our lesson, let's solve some problems. Wala sa manual to, so you have to take note of this. This is Moore method. As you can see class, direct lang. O ayan, chloride din yung analyte. So mole of analyte is equal to the mole of titrant consumed. Just multiply your molar and your volume and convert ng class to sa milligram. O diba? Very quick lang siya class. Dapat by now kasi na kayo mag-solve under ng mga classical methods natin. So for this problem, the chloride is 891 ppm. O see? Very easy lang class. And let's solve the problem there in your manual na Volhard. So iodide class ang sample here. First, you multiply the measured excess of silver nitrate. Sakto. 50 ml lang yung ginamit. O diba? 1 burette full lang yan. And then, ito class ang ginamit during back titration. So take note on relationship. Whatever the amount of titrant thiocyanate was consumed is equal to the amount of silver na in excess or unreacted during the first step. So ayan, multiply. You already have your moles, then subtract. So this is your mole iodide. Dito equal ang mole iodide. And then, gagawin na siyang percent. So mabilis na pala ma'am. Exactly class. Hindi naman kayo sobrang matatagalan sa Volhard. You already know the drill about back titration. It's just subtraction. So kailangan lang talaga class. Sanay na kayo dun sa concept, dun sa method, and saka i-apply yan sa problem solving. I keep on telling my students na ang problem solving, hindi siya magiging full circle moment kung hindi mo alam yung method, yung concept. So you know the chemistry part first. That's the principle, that's the concept, the method. Then you apply whatever you know in math to solve the problem. Use your operations, dimensional analysis, etc. See? Ganun class ang problem solving para effective, para katama kayo. So now, we reach our last topics na. So ito na class, complete na ang niche list natin. So we already have here our Volhard, Moore, and Phagans methods. It's up to you guys if you want to use this while you are solving. Kasi in on-site sections, share ko lang sa inyo 1A, naka-flash to sa kanila. Naka-flash to kasi nasa-saturate daw sila sa dami ng mga inaaral in a day. 1 day nila ay devoted na talaga for Anakin 4. Okay? So ayan guys, ang list of reactions and relationships. Also, I would like to share with you guys ang molar masses. Ito ang kailangan nyo for calculations for Anakin 4. Medyo marami talaga problem solving here. So there are 3 conceptual questions na medyo problem solving din actually. Kahit walang numbers, mag-iisip ka pa rin para din siya problem solving. Okay? So class, hopefully, kaya nyo tong tapusin. In the on-site sections, they ask for extension. So 1A okay lang. Kung mag-extend kayo ng slide, hindi pwedeng sobrang okay ng pag-extend niyo kasi class sa board exam, limited lang time. Here in every practice test, we give you only 10 items. It's quite weird if you're spending hours for a 10-item practice test. Kasi class sa board exam, yung 100 items ay para lang sa 4 hours. O bawal kayong magsabi naman, 1 hour na ako sa 10 items. Hala, sa board exam, ganyan nakabagal, hindi pwede. So kaya may training na agad here palang class sa practice test natin. Alright?